So we're going to look at how to determine the combined instrument reflector offset. Before I do that, I want to mention that the National Geodetic Survey has established several calibration baselines across the United States. This is a map of where those calibration baselines are. You can see in some states there's very dense calibration baselines, and then in some states it's fairly sparse. In fact, in Iowa here, there's only one right on the border with Nebraska. So in any event, these are where they are, and what you'll see in a calibration baseline report is this. First of all, it's coming from this website right here, and this is a rendition of what's on the report. I took something from a report that's close to Butler in Pennsylvania. It goes from 0, it has an elevation of 100 meters, to 150, which is 150 meters away approximately, and its elevation is 99.472. The horizontal distance then is given as 149.9983, and the mark-to-mark distance, and this is the important thing, it also requires a mark-to-mark distance, which is on the mark on the ground to the mark on the ground. And you see there are different elevations, so therefore it's slightly a slope distance. It's 149.9992. Now this is not the same slope distance you'd be reading from your instrument. And then it has a standard error of 0.1 millimeter. And you can see this continues on. They have a 430 mark and they have a 1020 mark. And the elevations vary significantly as you go down here. But what they have is these two adjusted elevations. Now to use this, you actually have to follow what's in the NGS manual number 10, which is the use of calibration baselines. And unfortunately, this requires a reduction of distances to marks on the ground, which means we need mark-to-mark distances. And it also requires a least squares adjustment, but it will determine both the instrument reflector constant and the scaling error of the instrument. So it has that advantage. It'll get both things from your instrument. What I'm going to present here is a method that allows you to quickly determine what the EDM reflector offset is, and then use that in your instrument. So the procedure is straightforward. You first of all start with your instrument in metric mode. You then establish 3 points on line. So you set up on one of the endpoints and you sight down the line and establish 2 other points. You'd like these points to be multiples of the fundamental wavelength of the EDM. Typically that's 10 meters. So it can be 10 meters, 20 meters, 30 meters, and this could be like 50, 100, 90, whatever. You just want multiples of those fundamental wavelengths. The reflector itself should be held by a bipod or tripod. It should not be handheld. You'd like to have it at the same height of the instrument, and that would give you then, on the slope distance, the mark-to-mark distance approximately. So it will give you a check, but that is not the mark-to-mark distance. That has to be reduced from the actual measurement. What you do not want to do is handhold this reflector. So like I said before, the procedure is fairly simple. You set up 3 points on a line, and that's the important thing. They have to be exactly on a line. So you set up one endpoint, and then using the fundamental wavelength of your instrument, you set up multiples of that so that the distances are slightly different, and here I chose 10 and 50 meters. Establish both A, B, and C so they're on a straight line, because if you don't, you'll have a triangle, and then you'll be measuring across that triangle. Observe the length AC, so the first distance you want to measure is from A to C. Then you'll move your instrument to B, and you'll measure BC. Turn your instrument around and also measure AB. And so you'll have horizontal lengths, and that's what you need is the horizontal lengths in meters for AC, BC, and BA. Once you have those, you can compute your K. And the K is there because of the fact that the glass and the reflector slows down the light and therefore makes all distances appear to be too long. So BA is BA plus K, BC is BC plus K, and AC is AC plus K. Now when you rearrange this and solve for K, you get that K is equal to AC minus BA plus BC. This will always turn out to be negative. Now with that said, that doesn't mean that you actually use a negative in your instrument, but I'll just leave that go for right now. Right now what I want to say is when you do that once, you want to do it several times. You will then go to your instrument manual and see if it's within the technical specs. So if your EDM is 2 millimeters, then you want it within 2 millimeters or approximately within 2 millimeters. If it's 3 millimeters, you want it within 3 millimeters and so on down the line. If it's not, you want to enter that difference into your manual. Now it actually helps to start off with your prism offset actually set at 0 in the instrument, and then you'll actually get the number to put in. But if you don't, let's say your instrument is set at negative 20 millimeters, and as I say, they'll always be negative, and you find out that it's actually a negative 30 millimeter prism that you're using with the instrument, in that case there, you will get a K approximately of a negative 10, and you'll have to add that negative 10 to the negative 20. So you'll get your negative 30 in the instrument. That's why it's better to start off with 0 in the instrument. The other thing I want to say is that when you purchase an instrument, it usually comes with a matched set of reflectors. And so that means that when you use it, you don't have to worry about doing this. In fact, the only time you have to really worry about doing this is when you flip reflectors with your instrument. So if you don't keep the reflector that you bought with the instrument, or if you didn't buy one with your instrument because you're using your older ones, this is when you need to do it. So again, what you want to do is, first of all, look at your manual. The reason I say that because I know of one manufacturer, even though it's a negative, for instance, 30 millimeters, they actually tell you in the manual to enter 30 millimeters and not negative 30. So if you put in a negative 30 millimeters, you'll be off by 60 millimeters, that kind of thing. So just make sure you do that. The other thing then is when you do this, after you do it, check it. Do the whole procedure again and make sure that you end up with a K that's close to 0. It should be within these technical specs. Just remember that you should use a calibration baseline to get your better estimates of K, but that involves considerably much more work. And it also is a problem of the calibration baseline is not necessarily being close to you. So in review, the best procedure is to use that National Geodetic Survey calibration baseline method. But if that's not close to you and you need it immediately, or if you just don't have access to it or don't know how to do the computations for the mark-to-mark distance and the least squares adjustment, and that's all laid out in their manual there that they give you, then what you can do is this method. It'll provide a quick check to make sure that your instrument and reflector are actually matched and that you're getting the correct distance. And that concludes this lesson.